So what we're going to talk about, you heard about machine learning models. We're going to switch gear a little bit and talk about different types of models and model-driven management in the concept of networking in general. And this morning was all about automation. And we see, as we go through network transformation projects, all over the world, that we add virtualization and we add all sorts of other new technologies, we increase complexity. So we add complexity in our network all over the place. And with that comes additional effort required to deal with that complexity. So more people doing tasks, more automated scripts trying to figure things out. And with that, we increase our TCO. And so to reduce that, we're introducing automation. And that's why we see these conferences heavily biased towards automation, a lot of information going on in automation at the moment. And that's to try and mitigate some of this additional complexity that we bring in, reduce that risk and increase the OpEx for a company. But let's diverge slightly. Well understood communication is really the key in all of network automation. And a good example is the Mars Surveyor mission. So back in 1998, NASA launched a probe or a rocket up to go and orbit Mars and understand the climate change over a long period of time around the planet. So in December 98, they launched the rocket, spent a good few months traveling there. It got there around September 99, and then they launched the probe that was going to go around and sit in orbit. What they actually did, though, was launch it 90 kilometers closer to the planet than they'd anticipated, and about 25 kilometers lower than the survivable rate. So they immediately lost it. So they traveled all that way and immediately lost the probe, and the mission wasn't a success. And they spent about a week trying to figure out what had gone wrong. And what it turned out is the engineering teams in Colorado had communicated some data to the mission control in California. And one team thought that they were giving those numbers in imperial, so feet and inches, and the other team thought they were getting the data in metric. So the calculations were all messed up. And ultimately, bad things happened. And that's true when we talk about networking devices. We need to talk from networking devices to controllers in a very clear way. Anyone who's listened to any pilots flying airplanes or hear anyone who works kind of on radio systems, emergency services, they use this ABC mnemonic: accuracy, brevity, and clarity. And it's true with networking. We need to have clear, very structured communication that's well understood. We as humans are all very good at talking in different languages. And even if we're talking in the same language, and even if we're native speakers, sometimes the meaning gets a bit messed up, and we've seen that. So we need to define something that can be readable and understood by humans, because ultimately engineers are going to do this work. Also by machines, though, we see, we want to move towards fully automated systems where machines understand what's going on. And if we don't, we have to compensate. And compensating ultimately adds complexity and ultimately cost. And we have to understand everything that's going on. We have to really kind of predetermine, I'm going to talk this way, you're going to talk this way, so I need to understand what we all mean. And that's hard. It introduces cost. And the way to get around that is to make assumptions. We all do it. In human communication, we do it. I say something, you assume I meant something. You might be right, you might be wrong. But in the case of the Mars orbiter, that assumption caused a fairly fundamental problem, and they lost the mission. So really what we're saying is the content here is what matters. Content and understanding that content is really the key. So when we talk about network devices, we're talking about models developed to make sure that content and communication is understood across all vendors, all network operating systems. It's a standardized way of talking, so we're utilizing Yang here. It was developed for networking devices. And we're using that for networking devices, and pretty much every vendor is doing the same. And Yang is a modeled language that defines things like leaves and containers and lists, and ultimately you end up with a tree structure, and you see one on the right there. A tree structure of data that's modeled, and you understand what each element means and what unit each element should be in, so you can avoid miscommunication. And with these tree structures, they lend themselves extremely well to traditional network operating systems. We're all used to typing things on CLI. Well, most CLIs are inherently some kind of tree structure. You drill further down into your config, you make changes, you drill back out again on router interfaces, certainly. So now if we take that tree structure and we model it, we can plumb our data into it, and we can make multiple copies of our data potentially, which gives us some great benefits in terms of taking transactional behavior, taking a model filled with data and applying that to our device, which already has a superset of that data in a modeled language. Same with state. We can store all of our data from routers in a Yang model, a Yang modeled environment where we can hold all of this operational data. So what is our router kind of doing? And because we have this Yang model that defines how everything should be, it's really easy to understand. Now, of course, you can model anything with Yang if you wanted to. You could model how big was my router, what's my physical dimensions of it. I could model my services. What is a service? What is a VPN to a customer? I could model billing profiles if I wanted. So you can start using this language for more than just router operating systems. And it brings us some really good benefits. I'll give you some examples. If you have a Yang model that defines how your router should look, your router configuration should look, as an example, we can take that Yang model completely offline without the need for a router and create a validation sheet. And we can do that automatically. We can do that in code. And then you can take some data, and I can plumb that data into that validation sheet and automatically generate the configuration. And that doesn't have to be a single vendor's configuration. If you've got these models, you can plumb your data in and automatically generate the configurations in whichever vendor model you wanted to. Or in standardized, more generic models, you can do exactly the same thing. So auto-config generation is definitely one of these things that is going to help us with automation, as you heard all this morning. On top of that, we can utilize it for auto-generation of other things. And user interfaces is another very good example. You can take a model and you can build your user interface automatically. And it automatically can generate all the fields and all the plumb-in data and all the forms you need to configure your device. But the nice thing about this, and the really important thing about this, which comes back to this kind of automation piece and this machine learning piece, is you don't have to predefine all of those forms or all of those GUIs. The model can be read in on the fly, and you can generate on the fly how your system's going to look and feel. So you're starting to automate not just router configuration, but you're starting to automate user interfaces as well. So it's a step further forward. And it's all from this base content, this base modeled content. Now, if we're saying that content is the most important thing, then actually we all know we have multiple different ways of accessing networks. You heard this morning about gRPC. We have CLI. Everyone is used to using CLI. And although we're talking about automation here, CLI is still going to be around. It's still going to be used. It's not going away. Engineers like fixing problems on CLI. It's an important tool. We shouldn't forget it. NETCONF, another protocol for being able to configure our devices, or get state information, or get notifications, or perform actions. And these are all very useful ways of accessing devices. But ultimately, it shouldn't really matter how you access your device. What should matter is the content. And at the heart of that content is our Yang models. So long as you've got this consistent Yang model approach, automation becomes quite straightforward. If we look at it in more detail, if I have a very, very basic Yang model up on the top right, and I want to define in Yang how I'd configure a router name, host name. Okay. Very, very straightforward Yang model. We have a container, we have configure, we have a container for system, and we have a leaf for name. And all this builds is our tree structure that says configure system name, which you could write in a CLI on one line, or you could write in a hierarchical way. It's up to you. And we define what that name, what type that name is going to be. So what we're essentially doing here is building that table, building that plumb-in GUI that says this is my field and it's going to be this type. And if I talk about a CLI, the data I'm going to insert that's going to match that model is going to be configure system name foo in this case. It's pretty straightforward, and it matches the model. But because data is the important thing, it doesn't matter whether I'm doing it over NETCONF. There's the exact same transaction in the middle for NETCONF to configure the system hostname, modeled in the same Yang model. So configure system name foo, you see, still exists in the middle. It's still the same, really consistent. And even if we go to gRPC and I decide that I want to stream this information to me or have this information given to me, it's going to deliver it over the protobuf files that we were talked about. But ultimately, in the middle of it, the data is modeled in Yang. So again, configure system name foo. And because this stuff is really consistent across all of our interfaces, automation becomes a lot simpler. You don't have to think too hard about, if I do this in gRPC, I've got to do it this way. If I do it in CLI, I've got to do it this way. An operator can flick between typing something on a CLI and know exactly what they type is going to be exactly what appears in their NETCONF transaction or whatever it happens to be. So that gives us some powerful use cases as well. If we take a look at a kind of very abstract architecture for a kind of model-driven management setup. At the bottom, you have your network elements from various vendors. And above, you have Yang models. And every vendor is going to give you Yang models. And there are also standardized Yang models. And what we want to do here, though, is not pre-program everything. We talked about, the previous speaker talked about machine learning and this kind of understanding that the machine should do a lot of this stuff for you as well. Same is true here. If I turn on a network device, what I actually want the network device to do is tell my management system, which is kind of shown here as a large collection of boxes up the top. But if you think as a general management system, where all of those could be individual or joined together, we want our device, as we turn it on, to tell the northbound interface, hey, I exist, and here's my model. This is how you describe me. This is how you talk to me. This is what all my fields mean and do and how they're modeled. And then we want our controller, let's call it controller. Controller means a million different things to a million different people, but let's call it controller. That can take the information from those models and automatically generate what it needs to. It can automatically generate its GUI if it's graphically driven, but it can also automatically generate its APIs, its northbound APIs. So now people can talk to this controller and understand how to communicate with the downstream devices. We can also use this same approach to stream information in the same modeled format up to our unified controller and into our data lake. You heard data lakes being mentioned as a key piece here, storing all of your data. Now, I know storing all of your data is somewhat complex when we come to regulatory discussions, but conceptually, storing this data in a data lake is important. And if it's all modeled, you understand how that data is stored, it's really easy to access and to get what you need and what you want at any given moment in time, which can facilitate much more detailed network reporting. It can facilitate machine learning. It can facilitate automated infrastructure management and configuration management. And we can hook very easily into our commercial systems, our business support systems, whereby people can provision services. Maybe I've got a standard model of what a service looks like. I can provision it down through my auto-generated APIs and provision all manner of different vendor equipment in a fully automated way. So it gives us some nice benefits by doing what is a relatively simple thing, making this model. And yes, it's going to take some time to really generate these models, to sit down and really go through them and make sure that the model you create is the model you need for what you're planning on doing. But that time and investment is well spent. So if you're looking at this stuff, spend a lot of time looking at the model, spend a lot of time going through it, spend a lot of time understanding how they work and what they do, because they're going to be key to how the rest of your infrastructure northbound is going to deal with your network. And what it enables us to do now is to utilize this modeled information to close this loop for automation. So traditionally we think about automation, we want to do something, okay, I'll go away and do it, then I'll figure out what happened, and that's my task done. What we want to do now is pass information between all of these different stages and keep doing it. So what do I want to achieve? Maybe it's optimize an LSP or something. Okay, well, I can pass that information into my system. I can decide what it is I actually need to do. I can do that action. I can make that action happen in a modeled way. I can pass that information to my router device to configure my LSP, for example. Then I can say, actually, I also need to get some telemetry here, so I can now get the telemetry from the device, again in this modeled format, gather all that data, pass it all around to our system from our data lake, run our analytics and correlation systems on it, really understand what's happened. Did it work? Okay, maybe it did. Could it be better? Well, let's have a look. What have I done historically? We can make new decisions. We can pass that information back into our loop and repeat and do the same thing again. So it really gives us this ability to gather loads of information in a structured, well-understood way, knowing that the content here is what I really care about. And it doesn't matter so much whether I'm doing it over gRPC or NETCONF or CLI or carrier pigeon. It doesn't matter. So to conclude, what this brings us is the ability to give us really good programmability of the network. I can make actions happen on that network, whether it's configuring services, configuring network elements, doing zero-touch provisioning, or dynamic network optimization, so taking the LSP example. And then having made those programmatic changes, I can see what happened. I can get all this data in a modeled format, stream to me, really understand what's going on, and make proactive decisions. And it enables us to have greater usability of our networks, which is really what we want from this stuff. We can start to close this automation loop and make decisions based on data that we're gathering from actions that we've performed, and then go around and do it again, and keep optimizing and keep making things better. And most importantly, in some respects, actually the people who operate these networks today, the engineers, if you ask people to do something once, they're happy. A couple more times, less so happy. Could you please just do the same task repeatedly? they tend to get quite upset quite quickly. But if we can do this model data and start to automate these processes, we can release our very good staff members, our clever staff members who we hired to do really interesting stuff on our networks and bring us real benefits. We can release them back to do more interesting, more useful for our businesses tasks. So really, the thing to say here is that content is key. Content is the really important thing here. It doesn't matter how I communicate with my devices. It matters what I communicate. And it matters that everyone can understand what I'm communicating. So model content is really going to be the heart here of all of your automation systems. And that's me finished.
Thank you very much, James. Any questions here? I think we're a little bit behind. Thank you very much.